talent-wise, we have the biggest opportunity. Unfortunately, exploiting opportunities-wise, we are the smallest fellows. As is clear, even small countries like Israel and all have really exploited. Singapore, Israel and all these have really exploited these opportunities. We are falling lagging behind. That's where we are all set to make a difference. The center of excellence. Okay? The user organizations are all of these you mentioned. Defense, government, PSUs, large enterprises, small enterprises, global capability centers, startups, you name it. Okay. Right? These are all proper research reports, guys. Not pulling these figures out of a hat. For example, $50 billion by 2020 projected by McKinsey report and all of this. You can go to our website, dsci.in, if you want to read more. Yeah. Demand, skills, awareness, what are we doing? What are we doing about it and where can you contribute? Wise, we are doing. You should get involved. If you are anywhere in the vicinity of these areas, you should get involved. It will help you significantly. First, only when I create the hunger and the demand, then you would really know about it and get into the next steps. Otherwise, you would not even appreciate it. Next. Okay, government is very keenly after this. You want to set up a research lab, it get you funds. You want to do a project, it get you funds. On, right? What is homomorphic encryption? Anybody?
Encrypted data.
Yeah, exactly. Okay. You're putting a lot of stuff onto the cloud. You do not know who's reading it there.
Yes.
Okay. It could be a system administrator, it could be anyone. Okay. So critical information, nature, personal nature, and all these things. You would probably put it encrypted. Now, how do you perform analytics or AI on encrypted data? That's the next challenge, right? So this is all got to do with that. Then quantum physics is here. Okay, so this was one of Einstein's postulates, right? So postulates saying that why you don't believe in, oh, it's some black magic, quantum mechanics. So there are two particles, since you have this, they are entangled, they are called. So it seems if you change one, the other one will change automatically. And in that equation, distance doesn't figure. So what happens is you separate these particles by 10 million light years also. If you spin one, the other one will get result. How? Black magic, dark energy, dark matter. Most of physics is unknown. Most of the current physics we know is unknown. I mean, it is only a small part. The other part is not known at all. And probably what we know is very little. What we don't know is more. But this happens. It's been observed to happen. So they've utilized it in cybersecurity. What they've done is they've taken this entanglement property and said that if keys are compromised, then they would get to know of it by the time it reaches the other side. And something as tampered with it using Schrodinger's equation and all that. So if you've done tampered with it, suddenly it has changed en route, and at the end of it you will be able to make out. A little involved in what I mentioned, but just look at it. So it uses that quantum key distribution protocol for network security. There's heavy research going on, guys. They're already there. Then solutions to attacking. They say that if you were to, quantum computing were to really come up, then computing will become so fast that you can practically crack all keywords. Apart from the other good things it does, one of the bad things is all current passwords and all the stand compromised, all security mechanisms. Okay. Move on. Cyber security. So which one do you want me to talk about? In 1 hour. Okay. These are the things: mission critical assets, data security, application security, endpoint, network security, perimeter security. In these there are many areas. Take your pick. DLP itself is data leak prevention. To all the other areas. Okay. So you see, prevention is very important. Policy management is very important. Operations is extremely important. The soft knock monitoring, right? So you see the outside threat. So all the data centers and all of these would have to follow these, because there are a variety of ways in which you can get compromised. And there, so I'll dig into this a little later, but this is a vast topic, as you can make out. Okay, this is just to get you a flavor of what's there, guys. I don't intend to really explain everything. I can't, right? Next. Cybersecurity stack. If you want a stack view of things, from the lower layer to this entire thing is cyber layer. So see this crown jewels analysis. What is crown jewels analysis? What are your most mission critical assets? To vulnerability assessment with weakness analysis to threat susceptibility and remediation processes. So in each one of these there are these securities there. So there is the assets level to infra, all the way it goes up to the personal one to organization and government level. Okay? Yeah, the next one. They're a little more technical. Network process application, for those of you who are fond of those Icete, physical layer, data link, network layer, session, presentation, and so on. So what are the different things that happen at every level that helps in this stack? Okay, what do you do? How do you ensure the reliability of transactions underneath the encryptions and the end-to-end connections, everything. Okay, yeah. Next one. Like this diagram? Before you leave here, I want to memorize all of these. Okay. Okay. This is the cyberscape in the sense when you're thinking that what are the companies really out there? Management, risk and compliance, little difficult to read. Okay. You see this security ops, data security, mobile security. You have digital risk management, blockchain, fraud and transaction security, cloud security. Those of you interested, application, endpoint, web security, and network and infra security. Levels of these are all the companies that operate in specific areas. Okay. Right. Next, AI and cybersecurity. Okay, AI-based cybersecurity. Okay. The threats are also AI-based nowadays. And put a simple password, whatever it is, ABC123, pick your name. Okay. And you have to put it up. How many days will before you think there is any threat?
Few seconds.
I guess it's somewhere close to the truth. You can set your clock within 5 minutes, you may get hacked. Okay, because there are bots which are running, and many are AI based. So you see this cybersecurity, the CBN Insights is a reputed paper, 80 plus companies securing the future with artificial intelligence. Anti-fraud, by the time this is done, there are many more, I'm sure, because many of the other companies are also introducing AI into their products. Okay, predictive intelligence, behavior analytics, anomaly detection, automated security, cyber risk management, mobile security, anti-fraud and identity management, and the app security, IoT and deception security. Put it as these 5. Predicted offense. What is predicted offense? So you would be able to predict override switch. That's where the crash happened. That is the software took over. Right. Now if you were to take an autonomous driving car that has more software in it than a Boeing aeroplane, please realize the impact of this. And this autonomous driving car is a spectrum. It is not fully autonomous at one end, it is fully autonomous. On one end it is fully manual. And there is an entire spectrum in the middle wherein it is taking increasing amount of control and taking many decisions on your behalf. Okay, so this is not some futuristic faraway thing. Nissan has built a development center in Trivandrum or Cochin, I forgot, which is developing software for autonomous cars today. It's developing it. Another, so they've told me that they are doing something called V2X software. China is pouring billions of dollars into that. What is V2X? It is V2V is vehicle to vehicle, V2X is vehicle to anything. Okay, so you would have use cases something like, if you were taking your car on the road and there are a bunch of cars ahead of you, then it will lock the cars into a convoy mode in which if the first car applies brakes, suddenly all the other cars will not crash into it, and so on. Or there is the other use case wherein if your car's health parameters are automatically sent to service stations so that they know more about the health of your car than you do. So supposing some part is worn out or needs replacement, they will automatically get a notification and be able to do it. So in that fashion, there are thousands of use cases, right from interacting with traffic lights to doing everything. This is predicted offense. So today you give your car to a mechanic, he'll do something. Tomorrow you give your car to a mechanic, that mechanic and people better have to be very highly qualified to upload software patches onto that. And if this car, a VIP is going to sit in it, you better watch out what those patches are going to do. Just a small thought. Adaptive systems. So when all these offenses are happening, how do you adapt yourself in real time? Because there is no wait time for your response. It has attacked, it's going to infect everywhere. So your systems also better have to be intelligent and automatic. You cannot wait until manually you say that, yeah, this is coming, and after that you take steps and measures. There's no reaction time. It will spread like wildfire. Across the globe, in fact, because you are interconnected now. Right? These are at planet scale, many of the applications. So those better have to be, these adaptive systems have to be very, very adaptive. They have to react instantly to thwart those threats. The fourth one is cyber analytics. So you examine the stream of traffic, you examine the patterns, you examine the behavior, and do a lot of analytics on it and AI on it to be able to establish what is a threat, what is not a threat, and how much of it a risk it is. So nowadays they are selling even cyber insurance. Okay, companies, how many of you are aware that they are selling cyber insurance? Measures they have to calculate. A lot of analytics, the base of analytics it depends on. Trustworthy engineering, what is that? That means if one part of the system goes down, the other is still functional. The others can still be trusted, it will still give an output which is very much solid and can be trusted. And the fourth one has to do with privacy, which we will quickly go through. And how much time do we have? Time is up? 10 minutes, yeah. You can go to privacy. Yeah. What is privacy? What is data? Okay, critical data, sensitive personal data, personal and data overall. These are the different categories. Next. Yeah. So, how do you classify the data? You're trying to work on it, which is sensitive personal data. There are a plethora of processes and functions and multiple touch points of privacy. Right? You may be an ATM machine, you may be using your phone. Just telling there are many apps, common apps which I will not name, which are sending your data out to dozens of websites. Okay, a very popular payment app I will not name, that sends your data to 70 websites, 40 of which are in China, we have measured it. And it sends data even at the time when you're not using it, and it can send off all your data in 13 seconds. Okay. The problem is that there are multiple points, touch points, complex org structures, third-party relationships, and stratified privacy requirements. I'll quickly run through this because this is a little less known area, but it's very much growing. Yeah. Next. Evolving privacy landscape. You see all these places where these privacy-related policies are coming out. GDPR is one that you know, which is EU GDPR, European General Data Rights Protection. Yeah. Next. So, what privacy really is? Any data that qualifies as personal data and an individual can be singled out. So, for example, people do customer segmentation on e-commerce websites, saying that these are categories, yeah, these are men, these are women, these are children, these are all sorts of categories. Ultimately, they want to give more and more personalized services. What are your preferences? What are your everything, right? And then we can make more recommendations to you. That's improving your customer experience. But what is the ultimate segmentation, customer segmentation? That which is one. your one segment in yourself, because everything is customized to you, right? What's the danger there? You can be singled out. They have too much knowledge about you, okay, which is very dangerous. Okay, tomorrow even genetic information is going online. Okay, they can find out even without you knowing who somebody was, someone else related to you, where they are there and all. In US, they've actually caught a criminal based on genetic patterns. Okay, so he was absconding, they took his sister or somebody took his genetic pattern, and then where all blood tests are given all over US, and then they singled out this fellow was caught him somewhere. Okay, all sorts of used for good and bad. Law enforcement, yeah, maybe there is a reason. Okay, so this is the thing. So when it is there out there, all your details are out there, how do you protect yourself? Okay, and next. Okay. So it's country, society, culture specific and all. The worst is where people are targeted on basis of who they are and what they are. Yeah. Next. So this is to just give you a peek into the Protection Bill Act and all these constitute personal data, biometric, genetic, all these things, right? Passwords, everything. Next. Yeah, demonstrating compliance is a big nightmare. How does an organization do? If you make the laws too heavy, what happens is some people have some bigger companies have deep pockets to really do that and be compliant. The small ones like startups and all will suffer because it's load. It's like a large rock that you are tied to your foot that you are carrying along, dragging along. Okay. Next. Yeah. I'm going to skip a lot of slides. Yeah. Go next. Yeah. So what are all these? This just show you the nightmare that we are landing in because there is cross-border thing also going on. Okay. Next one. Go on. Next. The streaming. So there are 3 areas: consent, that you've given your consent, data audit, and data storage limitation. I'll just give you an example. So a friend of mine is running a startup. He wants to put healthcare providers onto blockchain. Okay, that means why did that need arise first? Because supposing you are in Bangalore for 10 years, so you went to a hospital. You used to take your family to a hospital and all. Then after that, you move to Hyderabad, right? All your patient records are there. Now you go to a doctor, he says, I don't know anything about your history. That means it is with the hospital. The data which belongs to you is with the hospital. But supposing you were to have a blockchain solution wherein all of them are there on that, they can put stuff there and anybody can access. Now you don't want anybody to access, so it should be encrypted because transparency is one of the things of blockchain. Okay? Now the key is in your hands. Now some health insurer wants to insure you. So you only want to provide him the records, say for past 5 years. So you will give him the key. You will say that yes, I'm unlocking this for you for past 5 years data. And then you can look at my data. It is valid. It cannot be changed because it's on. And then you can give me the insurance. Otherwise, you have to rely on what I'm ticking there and saying some bluff, right? So based on that, he'll calculate your insurance and give you. That's a legitimate use, right? Okay. So that's why this consent is important. Even if take it, process it, otherwise are they correlating with some other images searched on the net? This is dangerous stuff, guys. Okay? So that's why consent, how much you are going to store, and the audits must be compliant. Very important. So go on. Yeah. Transfer, I'll not get to that. But here you see various steps. Notice, purpose, consent, collection, transparency, accountability. A lot of tech stuff also behind it. A lot of legal stuff. This is just to give you a flavor. Yeah, these are about my last few slides. Yeah. Next. Data privacy roles. Look at these. These many roles are coming up. And there are credentials offered in your tech roles. New, hot, emerging areas. Yeah. Next. Regulatory compliance, risk management, all of these. Yeah. So you see how big all this is. Risk management is coming up and all. Architectural and technical is 12%. It's very big market, so 12% is also quite a lot. and the other legal and compliance move. Next. This is cyber security. This is the core thrust. I thought I'd put privacy because the new emerging cyber security. These many roles are there in cyber security, as mapped by NASCOM and DSCI. Against this, there are groupies. You can go to dsci.in, it's there. Okay. So, it spans from network security to cyber forensics to industrial control, and then it feeds, it goes along. So, mid-level, senior level, right up to the top. Okay? Yeah. DSCI is a facilitator. Please reach out to us for anything. Okay, they have my contact details, and we want to create a very strong ecosystem here. Okay, yeah. Got it. Thank you very much for your attention. Any questions?
Could not find that slide actually. So
Well, it can't be put in one slide. There are a lot of,
no,
it's
just
a large
like to
field.
know,
So,
I am from electronics background, sir, actually. So
Yeah.
currently I am working on machine learning context actually. So I could find, whenever, there was a question for Sundar Pichai on, in the Congress. The counselor was asking for, whenever, we make a move, easily Google can track us.
yeah, that's true.
Then how to protect or how,
See, if they're giving to you many of these programs, you really need to read my book. But if you're really taking services for free, say Gmail, whatnot, all of these, they are taking a lot of pains to set it up. They're investing billions of dollars to set up these lakhs and lakhs of servers worldwide and do that. Are they doing charity? Certainly not. Okay, they're a commercial organization. They're taking your data. And you have given the consent to them. Okay, if you wanted that level of privacy, you should consider moving to a paid service elsewhere. Right? We should happily protect you. Privacy requirements are much more stringent, and you can have encrypted mail. There are many variations. You have to pay for it. Okay? So that's one aspect. The other thing is there are many settings by which you can increase your privacy and all that. But it's a very vast and complex topic. I can't give you one generic answer. Yeah. Any other questions? Right. Thank you very much.
Have you with us today, sir, and to have the benefits of your rich insights, and your talks seem to provide much needed help, especially to those doing research. Thank you once again for your contributions. I would like to request our Dean Faculty of Informatics, Professor Premchand sir, to present a small token of appreciation for Dr. Sriram.
I'm thankful to Dr. Sriram Bridavolu for having come all the way here and enlightening us about the cyber security. I'm thankful to you, sir. And you are our alumnus, and I'm very happy. Everything, as you have seen, I have also seen. So, Sudha told me that to pass on certain remarks. I would like to pass on one remark, that I always understand money than technology. So there the money that appeared was $35 billion that India can claim on cyber security. So I expect that you youngsters grab at least together, some of you, 5 of you or 4 of you can together grab $35 million at least whenever you start your industry. Or if you focus on the world global scenario because you go to foreign countries, in the $213 billion, you grab $2 billion. With that advice, because I am simply giving this advice because there is a famous saying. All of you have heard about Dr. Sriram Bridavolu. Actually, Gurjad Apparao, you must have, all Telugu people are aware of Gurjad Apparao Garu, who 150 years ago, who was a great man who contributed a lot to the literature. Gurzada Apparao garu has written so many books and he has written in Telugu. And one of his sishyas or friends, Mr. Avasarala Surya Rao, has translated it into English. These are my remarks. Number one. Number two, I am not taking much of time, Sudha. 1 minute I will finish. Two issues I would like to mention, that in Tamil Nadu, we might have heard a case when this Aadhaar card was essential those days, that for every purpose Aadhaar card was asked. One fellow used these fingerprints and he created some 3,500 SIM cards. Some of them are on our name also, we don't know. And secondly, the data theft recently happened in Hyderabad. I don't know which term I have to use. That term has come to my mind. Probably that is related to your data security. Let us use the data security term, that may be a better term. That is between some individuals, between some parties, and between some governments. So with these two issues, I think Dr. Sriram Biridavolu has done justice to this lecture. Thank you very much for giving me this opportunity.
Someone told that you are having a room. Thanks. పట్టుకోండి అది ఇలా పెట్టండి సార్ అన్నమాట.
We have a next session on the evolution of AI thinking and products of the next decade. And the session speaker is
A very good afternoon to one and all. I cordially welcome today's session speaker, Mr. Raghuram Lanka. Mr. Raghuram Lanka is Assistant Vice President, AI Center of Excellence, Reliance Jio. Raghuram Lanka is currently working as Assistant Vice President in the AI Center of Excellence at Reliance Jio, driving AI for India efforts in the field of agriculture, education and health center. He has over 15 years of experience in the field of engineering and product management at Microsoft US, Microsoft India. He built products on holds, multiple patents in the areas of mobile, analytics, IoT and cloud computing. He also co-founded a healthcare startup on cancer treatment and from College of Engineering, Osmania University, University topper, and did his MS in Computer Science from University of Minnesota. He has a Scholar of Excellence, Gold Medalist from Business Analytics Program in ISB, Hyderabad. I would like to welcome Mr. Raghuram to the days for delivering his expertise on evolution of AI thinking.
Thank you. Can you hear me? You can hear me. We get a chance to talk and they listen, right? So, hi everyone. So, I'm a graduate of this college in 2001. It's an honor every time they invite me. It's like great to come and talk here. So, so I think in the next 45 minutes, we'll learn about a little bit about AI and machine learning, and then all the things that we have to do. So Ray Kasvir is supposed to be one of the pioneers of AI to begin with, the thing about AI is all about, like, first of all, it is intelligence, and then how do we make machines more intelligent? That's the whole concept, right? So so it is meant to actually help us, and what we do, we are actually trying to see how we can make machines to do. So first of all, we need to understand what we are trying to do, right? So let me start with a perspective to begin with, right? So when we started software engineering, we always started with building the necessary infrastructure for that. So the old age IT systems, and long ago, when we are not born, People used to talk about SAP, ERP and so on. They built a lot of digital stuff, converting the manual forms into software. And because of their work, we are all here, right? So we start with the building blocks of digital transformation, which is infrastructure. So think of the first databases got built, someone created all those tables for us, started storing data, and that's where everything started, right? So the next part of infrastructure, as they build infrastructure, they realize that hey, we need to automate the whole thing, because realize that a lot of these tasks are repetitive and can we automate that? Like that's where the programming started. So where we said, hey, rather than actually doing the same task again and again. So in the next decade, right, 2000 to 2010 is the decade of what we call as data. So this is where Google and all these guys came and realized that, hey, as part of this automation, a lot of data is getting created. Like every time a click is happening, I'm giving something about myself. And we don't have to store it in just in table, but let me actually do something more with it, right? Like, can I actually identify a little bit more stuff about this person and then start do something with it? So we started actually coming into companies which started looking at the value of data, right? So and then that's the last decade, or the current decade is all about, hey, now we have all this data, can I do something more with it, right? Can I personalize this? We call it as treatment of one, or personalization for one. Can we get to a point where we can truly understand everything that is happening behind the scenes, and then can we do what Ray Kurzweil is actually asking us, is how can we make these machines personalize a lot of stuff, right? So that's the overall perspective. I think this is the wave of AI, we call it as fourth generation revolution or whatever we can call it, right? Like where now it's not about collecting data, it's about what data is all there, there's a lot of data there. How do you use data for really providing benefit to the scenarios you're looking at? And so this talk I'll talk about AI, what does AI mean, and then I'll walk you some examples in terms of how it works. Okay? Next one. Okay, so what do you see from this picture here? This is A's. What else?
All types of yes.
All types of A's. Patterns of what? A. Have you seen this before? How did you know that this is A? This is not what we are taught, right?
Intelligence.
Okay, so yeah, next one. Right? So the true thing about AI or intelligence is that we don't have to actually see the data, right? You have never seen this data. Like imagine if each of these are data parameters, right? You have never seen this before, but you are identifying a pattern and then generalizing it. So what AI really means, next one. So he said we actually have an ability to actually look at certain pattern and generalize it to something that we already know. So here you have generalized, so the A's that you learned in school, you saw that hey, these pictures are very similar to that, and hence it must be A. Correct? So, so intelligence, the difference between data and intelligence is all about generalization. And you look at in every model that we build, it's not about the 4 or 5 data parameters you're looking for, the pattern you're identifying from it and then extrapolating the generalization. So let me talk about evolution of intelligence, right? Where did we start? So until 2014 or so on, the huge buzzword around was business intelligence, right? People are talking about BI. Right? So BI is all about, hey, okay, so and how did this evolve first, right? Once there was data, the first thing that you want to see is that I want to find patterns in this data. So you do historical analysis of it, look for patterns, and then say here is the dashboard of what happened in the past. So the first evolution of intelligence started with business intelligence reports, and that's where we call it as reporting the past, and that's where things started. Right? So then came that, hey, once we have, but that's not so interesting, right? Like identifying that I made 10 accidents is a good info, but will I make the next, as he was talking about, right? Like will I create the next offense or not is a lot more, I hope you're hearing, right? I'm actually not hearing. So it's, see, reporting the past has so much of value. What is more valuable is that can we predict the offense to actually be created, or can we predict it? So that's where the next evolution started, which is what machine learning is all about. So I have all this data, so you have an output variable, So where you're saying that I'm writing an equation to identify it and then using it to figure out, can I find the next yi given all these values that are there. So prediction is, machine learning is all about like predicting that one future given a number of things. Yeah, so then came the, okay, so the next one is all about, is the new thing, which is that not just predicting one feature, but can you predict all the features of all the possibilities of a given scenario. And that's what AI is. So in a game, for example, it's not about predicting the next move of the chess player, but can you walk through the entire stack and actually say that this person, all the 100 moves the player is going to make, and then create the entire tree order. Show it in a more diagrammatic way. Conventional machine learning is all about, imagine that I have a picture. What do we get? So should I use this one and say it? There's a very different way to this. So imagine I have a picture, right? So at some point in time, what people would actually do is that manually extract each and each feature. Imagine that I am actually writing a model for edges, for gradients, for identifying the hues and colors and so on and so forth. They all become the feature variables or columns of a table, and then given all of it, then you sort of like, I look at various models and then model for image detection used to work, and this was always there. It's not like deep learning. There's always someone who were hand extracting features out, right? So the new, the current evolution is all about like, yeah. So in deep learning, what do we do now?
Just we feed the data.
Just feed the data, something happens. So how does it actually happen? What happens in deep learning now translated into, you have a neural net that actually does the feature extraction for you as well. So for specific set of problems, you can be a more manual process in the conventional machine learning is now an automated process in deep learning, and hence we are able to solve so many problems at such a fast rate. Okay, so yeah, so that's the, so the other point is actually evolution of model inference, right? So where do we infer? So traditionally we always, so think of like I have, so let's actually look at, go back. Yes, be here. So think of like, okay, so he talked about IoT, he talked about a lot of devices, right? Today, there are n number of devices that are generating data for us. So, so our smartphone itself is one of the places. We talked about IoT, we talked about the security cameras generating data. So data is getting generated everywhere. But is the data getting processed and analyzed there? No, right? So data is not getting processed there. In a traditional model inference, the data gets transferred into cloud. That's where your models are. That's where they actually run, and that's where inference happens. So there's a difference between training and inference. How many of you know that? Yes? Makes sense? Okay, so training, you build a model. Inference is all about like, yeah, the model is built, you're inferring the answer, right? So traditionally, like this is how we call it as cloud computing in a way. You transfer where the whole latency, privacy, network bandwidth, all associated or the negative side back, because I'm taking, let's say a security camera is deployed here, it's trying to find out how many of you are attentive, it's getting processed in some cloud somewhere. So the latency for me to get a feedback that so-and-so person is sleeping there is going to take a lot of time. Right? So in the new world, so how do we break this problem, right? So you actually start like, you still have to build, your resources are still in the cloud, so you train in the cloud, but you can infer in the edge. So the new model is that instead of network latency and so on, imagine that I have a security camera here and then I just connect on my phone, I can see the inference right here and I get a feedback. I can make an edge level decision rather than going to the cloud. So this is the new paradigm of, we call it as edge computing, is all about like you still train at the cloud because you still have there's a lot of data that is there and processing requires that much of, and your GPU machines are there, your computing is all there, but you can do inferences at the edge level. Okay, so yeah, so this is the evolution of model inference. So what did we learn, right? So we learned that we are away from machine learning to AI. We are away from, at least from certain problem statements. We also are moving away from cloud computing to edge computing. And and that's where the new things are. Okay, so what are all the algorithms that are there? Did algorithms change? Algorithms haven't changed. It's the same set of algorithms that we still run. So let me walk you through like a few of them. Okay, so let me start with the first one, right? So what do you see from here? What do you see from the text here? Information about a drug. Which drug? Aspirin. Okay. And what is it saying? Saying something, right? This is a Wikipedia extract. It is something that is which we call as like unstructured data, hard to read, has something there, right? So extraction is all about how do we convert unstructured data into structured data so that you can do n number of things. Imagine that instead of this, I actually show you something else. If I say I actually show you this, so it's the same thing that is actually at the top, but very processed and then put in a certain way. Given this, can I ask a question saying that, hey, tell me all the, what is aspirin is used to cure for? It's right there, right? Can you say this in Telugu? Can you say the same thing in Telugu? Say it. See, so the thing actually is that the actual knowledge is language agnostic. Text is English, but language is not. This is what we call as knowledge. This is how our brain stores data. We don't store text. And that's the reason why we can associate, and we can do translations. And when you translate from English to Telugu, you will clearly see that you actually are not talking Telugu sometimes, or Telugu to English, right? You take Telugu sentences and then you put them into English format and then say. Because like we have stored so there is always this, and whenever you see something you think that, I know this somewhere, and you try to extract it out. Once you hit it, then your notes are all set, right? So this is what we call as the knowledge graph. If you hear that word, it's all about like convert unstructured data into structured data, and could be about an text here, it can be an image. See, when I see a picture of a cat, I'm not seeing the image of a cat and then putting it to deep learning to understand, right? I'm inferring that it's a cat, and then now I can say that, cats are this, cats are that, cats are this, and so on and so forth. What we are actually hitting is some node in the graph, and then you can do associations on. So all these class of problems are called as extraction problems. And depending on your use case, you actually use some of these problems for it. Okay, so next one, right? Now let's go here, right? So what do you see from here? It's an image, but then we actually do some what we call as interpretations of a number of things. And interpretations need not be on, you can see that, this girl is actually playing with a dog. It's not expressed in any text there, but you interpret that. Right? So interpretations is not just about image recognition, interpretation is also about understanding the context of the way in which the things are. And interpretations can be both on image or on text as well. Right? So what do you interpret? You interpret the entities associated, the aspects on which it's talking about, as well as on the sentiment associated and so on and so forth. You see that the girl is happy here. But imagine if the dog is barking, then you may see that the child is afraid of the dog or something like that. So you have interpreted it. So if you want to build a machine learning model to actually go and build this, so how do you go about building such problems? That's what all the interpretation problems are all about. So then the third class is the summarization problems. So summarization problems are, algorithms are all about, okay, so how many of you know about market basket? Market basket? So this is not we go to a market and take a basket. Okay, so think of like all our features are actually in an n-dimensional space, like my height, my width, and like whatever it is, right? So and they're all placed there, so in an infinite dimensional space. Now everything that are associated together all come into one spot. Okay, let me give a very simple example, right? So how many of you have seen Bahubali movie? Everyone has seen. Okay. So is there a difference? So if I actually take the Bahubali movie's features, right, and then put them, there's a Hindi version of it, Telugu version of it, Tamil, probably there is a Japanese version of it also, right? So if you actually put this into an n-dimensional vector, would all of them come together, or would they be different? What is the only thing that is different in all of those? Only language, right? Other than language, everything else is same. So imagine that if Bahubali movie has, let's say, 10,000 features, like the hero, heroine, and all that stuff. So for 9999 features, they are same. Would they all come together if you represent? If you imagine each one is a variable, so they will all cluster together, right? So that's what this whole, we call it as summarization algorithms are all about. Like, if you have to actually take n number of objects and put them together in space, things that are together all clustered together, and hence now you can start labeling them. So and then now you do click. Good. So now go back, right? So imagine that happened in any market out there. At any point in time, it doesn't matter who purchased, what purchased. I take all those bills and put them together. Then if all the entities that are together come together, right? So like for example here, like this is the cluster of all movies, irrespective of like who watched, all movies all come together because movies by their representation are all the same thing, other than the name of the movie and probably few features, right? So they all come together, and this is what we actually use for identifying how do I summarize this set of objects that came to me. Simple thing that we actually talk is like, hey, if I have a number of balls, each of them are different color, then you actually say, these are all the red balls, green balls, blue balls, and so on. So if a new ball comes into the system, you can easily classify it as well, right? Because of its color. The same thing goes here. So this class of problems are summarization problems, and market basket is one way of actually doing that. So the next one is, these are the classification problems. The classic thing is, okay, I'll take the cyber security example, right? So is this a real user pattern or not? Is there a fraud here? So if the question to me is that yes or no, right? How do you answer that? Are you coming to the class today? Yes or no? Right? So it's not like you're not going to give a essay type answer for that. So all those things that have a direct answer yes or no is all going to classification. And typically deep learning plays extremely well in such problems because you can label them very fast, right? Like what is this image, cat or a dog? So yes or no, and then now you put it in neural net to get pretty good answers. So this is where first right now all the deep learning is heavily being used. And you don't have to be. So the last example I was actually giving here is that it's a time series. So you can use deep learning in time series problems as well. Yes? Did anyone use that? Yes? Yes. Okay. So okay. So what patterns, what models would you use if you have to use? Okay. How many use deep learning? Okay. So where do you start? I thought this is like, what are you guys doing here? Okay. So let me tell a story of the story that he was talking about. Of a 10th class student, I'll tell you a story of a 10-year-old. 10-year-olds are doing TensorFlow, means that it's not that complex. All you have to do is just pull something and then put something there and something will come out. Come on, as he rightly said, it's a black box. Why can't you do that? Why do you want someone to actually tell you to put something there? I think the one takeaway you should all have is go right now, install TensorFlow and then do something and come back. That's how you should be. Okay. So yeah, so the models that you use for time series, there how many? There's something called as LSTM. LSTM models are used because they go for both long and short term memory. So you can use the time patterns. So it's not like just the current data, but then you can also look at historical and native also. So classification problems are some things that are extremely critical. Like that's where we do stuff, and yeah. So the next one is recommendation. Right? Recommendation is a huge thing. So today you are using Flipkart, you are using Amazon. Someone is recommending behind the scenes. They know that this is your pattern and they are doing recommendation for you. Google is built on recommendation. So recommendation is the core where the whole things have started, right? So about movies and so on. So yeah, so next one. Okay, so the reasoning is where the things are, right? So reasoning algorithms are also there. So how many of you use Google Maps to go from? All of us, yes? So today Google Maps actually tells you that if you put point A and point B, sometimes it actually says 52 minutes, right? 52 minutes you are going to spend to go from here to there. Look at how much the accuracy is right now. It's not saying 50 to 60, it's not saying about 1 hour, it's saying 52 minutes. So to get to there, they are utilizing a lot of data. Who is giving data for them to come to that number 52? All the ones who are ahead of you on that road, right? They are giving data to Google to actually say that, hey, I am spending for this small stretch of road about a minute. Imagine that the entire path is split into 52 points. It's actually saying that a minute for this distance, a minute for this distance, and hence it is coming up with 52. So everyone ahead of you is helping you to get that distance out. So yeah, sometimes data privacy is okay. Not having it because of such examples like that, right? So if it is used for convenience, So reasoning is where this is pure, it's not data crunching here, right? So it's reasoning, looking at all the data and then coming up with that, given everything that I know on the time frame and probably, and typically at this point in time, in the next 1 hour, this is how the traffic patterns are, it came with that number 52 for you. So that's where reasoning is, right? So yeah, so which move should I play next? It's all reasoning. So you build a tree and then you walk down the path and then see the min-max algorithms. Yes? Okay. So at least we are reading books now. So yeah, so what do you do, right? You do min-max and then you compute and then you come back, right? So that's what, it's reasoning with fundamentals. And yeah, so what should I say next, given that? So we don't tutor in non-sequential things that are not related, but things are always related, and that's how we make sense. Right? So yeah, so we can do in math. Can we do in mathematics as well? So I'm in a certain step. So can I actually say that, hey, what should I do next to get to my end result? Yes. So can we solve IIT using AI? Yes. Why haven't we solved it yet? Go back. TensorFlow. So this is the problem. See, mathematics is a very structured subject because it works on specific rules. So you know that at a state there are only 5 steps that you can make. So and then hence you can actually codify this, and then we should be able to say, now imagine that for an IIT paper, instead of one answer, you give here 100 ways to solve the problem. So yeah, we get bonus as well, right? So that's where AI is, and we can do this. Okay, so what's the architecture of intelligence? Yeah. Okay, so stop here. Okay. So let me take a step back, right? So we talked about data, we talked about models, we talked about algorithms and so on. And so let me actually step back and say, what does AI actually really mean? So let me give one example and then we'll thread through this. Imagine that I have fever. So I have about, let's say, 1 or 2.4 degrees, right? So I measure my temperature and then 1 or 2.4 Fahrenheit I have. So I then go to a doctor, and then he actually looks at my symptoms and actually concludes, asks me 2 more things, right? Hey, do I have cold? Do I have, I'm feeling chills or something like that? And concludes that, let's say I have a flu attack. So stimulus in this case is that I felt feverish is a stimulus, right? So and my state of being, the flu is the state. So the difference between both is that data always exists. Like I'm always here, I'm doing a number of operations and so on. A button click is a stimulus that goes into recommendation to actually say that this consumer right now is in state of purchase. Right? So think of like, stimulus always is all various data that come in, and state is where the whole knowledge kicks in. Now imagine if the doctor at this point, right? So he has prior knowledge, given flu, here are the 3 medicines that you would give for a person with a flu attack. So he has a prior knowledge that he is using to come with a prescription. And then that's what he actually says. He writes a prescription and gives it to me, which I go and then go to a shop and then purchase it, right? So the entire sequence of some data activity, the AC is actually currently showing something here, right? Imagine if we have to automate this process. So this data of that room temperature is 21 is the stimulus. Then imagine a model somewhere they're saying, should I turn off the AC or not? Is the room chilled? Is your state? And then the action could be that, should I continue the AC or turn it off, is the action that happens. And the response is that some signal comes back to this AC to turn it off. That's the response finally that happened. So that is how from any data flow to the response is how it actually happens, right? So this is how traditional learning is always there. The difference between this and then AI is that you also build a feedback layer. So imagine that the doctor gave me 3 medicines and then let's say that it didn't work for me. So I go back to the doctor and actually he said this is not working. So now he knows that with this medicine it is not working, so he tries something else. If the feedback is not there, for the next 100 patients he would give the same medicine. Yes or no? Because he doesn't know whether it is working or not. So he is in his knowledge always was there, right? His knowledge that flu means 3 medicines, right? But with my feedback, he tried something else and that worked. So for the next patient comes, they get benefited. So doctor became more intelligent. Right? So we call it as we learn, we improve. This is how humans actually do. does, right? So we don't, every day in the morning we don't wake up with a clean state. Okay, let me start with A. Right? We don't do that. We always are at a certain state. Then we wake up, we take that state and we learn, we add more and more to it. And that's how we keep on improving. If you are building an AI system without a feedback system is not an intelligent system at all. So feedback has to be an implicit part of all your learning and how you actually get the feedback back and then learn. Imagine you're building a simple model that given a picture it says it's a cat or a dog. So what would be the feedback here?
The correct response. Yes or
Yes or no? If I say cat and it's a dog,
no.
it has to come back to the system back and says this is misclassified. Then I would actually go and learn, oh, this is I misclassified, so let me learn now again. Cool. Here we go. Okay, so I'll skip this one. So anyways, yeah, so okay, so where are we right now, right? What's the state of art, given all of it? Hence I was saying you all should get out now and do, is that, so today, our learning, like machines, so okay, we have 5 sensory organs, right? More key are like eye and ear and so on and so forth. So today, we have good machine learning algorithms, so we call it as, imagine a certain level is human level defined by psychologists or analytics, right? So today machines are far better in identifying images than humans. Today machines are far better than identifying like captions, the auto captions that you see in from speech. Machines have exceeded like our human level and they are going far better than that. So 2 of our senses we have already given to machines. Only 3 more senses remain. Right? So that's where we are. And the reason why both of them are actually working really well is that, yeah, so each sense has a purpose. Like vision is all about classification. I learn and then I interpret and then I get answers, right? So yeah, cool. Okay, so let me talk about a few applications, right? Any questions before this? Are you scared? Do you want to work in AI? Do you want to build AI models? Yes. Okay. So what do you want to build? Right? What are all the applications? Okay. So let me talk about a few of them. Right. So I'll just open this page. Have you seen this video showing up in LinkedIn once in a while? What problem is going on here? Automatic number plate recognition, right? Hey, this is not a new problem. Huh? This is something that has been there for I think 1970s, before even I was born. So this is what police would actually do to identify this. So you can see that the traffic police out there, he would write in paper, or today he's taking the small camera and clicking pictures, right? So look how manual it is, how boring. So imagine I have a camera here, and then every time it's actually going, all it's doing is that it identifies that this is a number plate, identifies it, recognizes it, and then records it. This is feasible today. It's actually happening, right? So how is this? Okay, now it. So okay, so how is this built? Next. So okay, so I'll show this. I have an answer there. So this is built on something called as CNNs. Heard about CNNs? What are CNNs? Let in there one more NN. Okay. So okay, at a very simple level, right? Think of it like if I have a huge picture, I'm splitting into parts, and each part is given a specific task here, right? So it's a simple classification problem. What? Okay, now you see the picture and tell me what exactly is going on. What exactly is going on there? It's trying to extract the number plate. That I know, sir. How is it extracting it?
Moving frame by frame.
Frame by frame. Okay, it's not. It's moving frame by frame. Okay. Then what? Something happened.
Once it recognizes, it's making the color different.
Color change. Okay, you saw a green there, right?
Yeah.
Why is the color change?
So it identifies the feature.
Yes, match the pattern. Thank you so much. So okay. So now what happened is that look at. So instead of looking at this entire thing as an image, see, if I as human has to solve this problem, right? If I give this picture, you will tell me the number plate in like less than 1 second. Why? Your eyes actually immediately went to this number here, right? You ignored everything else. But if you are a James Bond, you will probably say this is Volkswagen, this is that, and so on and so forth, right? Because they look at more features. But like let's look normal human, we would actually go and say, hey, we would first identify that these are the characteristics of a number plate, which is I will see some white box with something there. That's the problem number 1. Problem number 2, once the green box is identified, problem number 2 is character recognition, right? So I'm not looking for infinite characters here. There are only 26 alphabets and then 9 numbers, right? So I'll just go and find them, patterns, and then I'm done. Very simple problem to solve. This is not complex at all, right? Agree? So we are going to build an ANPR as part of your course projects? Yes, okay. Now let's look at another example. So, okay, so now comes like, healthcare, right? So this is actually how a CT scan actually looks like. Think of like CT scan is nothing but a collection of n images that are both horizontal and vertical. So if it's finding for us so hard, imagine a doctor is looking at this teeth head. So that's what they're saying. So now you're like, what the heck is going on? Why is this thing that, right? Okay, so what are they doing? All they're doing is that, if you actually put this in a linear space, these are nothing but about maybe 80 images or something like that. So, and then they are being played one after another, and hence you see that visualization. But for each of those, there is always like, there is something that is normal and something abnormal. First problem statement, classify into, is this normal or abnormal? That's what doctor is doing. Okay, so they got this. Okay, next thing. Let me actually walk through that. Now this is abnormal. Let me see how much that patch is. And then they are actually trying to figure that out. So this problem, again a classification problem, and something that you can have any AI problem should be able to solve, right? So this is where the medical imaging has transformed a lot these days, where if you see that, right, like where AI has completely taken out, like, for X-rays or CT scans, MRIs and ultrasound, name anything, it's a simple 2-class problem to begin with, and then you can start labeling. Given it's an abnormality, can you label that abnormality as? So next one is that, hey, each one has it looks obvious the same to us because we haven't learned this yet. But once you know, there are various types of hemorrhages, and then you start labeling. Okay, so that's on the healthcare. Okay, so that's next problem. Okay, so next problem is okay, so this is actually on the cancer treatment. So something that I think maybe an opportunity for all of you to think about, right? So so typically, right, like I'll just give a 2-minute introduction on what cancer is, right? So cancer is nothing but you have one cell, that a rogue cell that came in and that our own antibodies couldn't work on, and hence it starts multiplying. Biology 8th standard that we learned, right? So single cell and then keeps multiplying. After a certain point, it comes to a point where it becomes noticeable to us. So by the time it becomes noticeable, we have already, that disease has been existent for a few years before it becomes visible. But because there is no visible identification, you cannot identify that, right? But you can actually use methods to actually find out tumors and so on and so forth. And how do you identify that, right? Like imagine if everyone is walking through the security scan of airport, we are all generating thermographs there. They're using for I don't know what, right? But we can use for early diagnosis of our own problems there. So along with security, cyber security, please use us for helping our health also. So anyways, right? So we are all giving our thermograms, they are all looking at heat maps. Also help us tell us if I have any abnormality or not. How can you do that? All of us are walking by airport. So imagine that if I can stamp that thermogram right there, abnormal growth on my hand or any place in the body. Right? So this is another place where early disease detection can really solve, right? Next one. So okay, so not just for humans, we can also do for plants and everywhere, right? So think of like to a normal human, both these pictures look exactly the same. So how do we actually say this is a problem of a disease versus like a nutrient deficiency? So, but if I zoom in, you can find that the characteristics of the leaf here are very different from that. That's an expert can actually say that. So how do you codify it to actually go and say it? Next one. So your first problem is that we identify the problem and then you sort of like put a label on it and then you say that hey, this is whitefly, this is that and so on. Okay, next one. Okay, so now okay, after all diseases and so on, let me ask you another one. How many of you played PUBG? 1, 2. Okay, your professors are all ahead, so they can't see you. Okay, so think of like, can we do AI for some things that are very creative as well, right? So look at like, you play Fortnite or you play PUBG, you play any game. but I don't like the visuals of this game, I want something else. Right? In virtual reality, this always happens. I am in the classroom, but I want to be actually in an open area with all fountains and all that stuff and so on. I want to be personalized to me. So how do you generate infinite personalizations? How do we get to treatment of one? How do we get to personalization of one? Can we ever do that? Is it possible? Can you convert a game which is having visuals like this into a game that I like the most? Yes, because I am saying so.
Yeah, we are.
Huh?
Yeah, we are.
AR VR is not about personalization of one. Think of like you are looking. Imagine that you and your friend next to you are looking at the same video. When you saw it, you saw Hawaii. When he saw it, he saw Bali. That is personalization because you are associated with it. So how do we create visuals? How do we change personalization? How do we create personalized experience on that? So okay, so yeah, so this is what is called as like AI is now coming into what we call as creative world, where you can actually convert any instance objects into any other instance objects. You can convert apples to oranges, or you can convert horses to zebras, right? So you can do that. So how do you do that? So click. Okay, so let me start with, I'm going to give you a 2-minute Gyan session on AI. Okay, so imagine I have a panda here, right? So press, click. Okay, stop there. Okay, stop, go to the next one, stop. Go to the next one. Okay, stop. So imagine I have a picture of panda. This is, you are going to listen very carefully and answer this. So I have a picture of panda. So I take some random noise, right? Just RGB pixels I have. So let me multiply with some multiplier, some constant, and I get back panda. Correct? If I put this to machine, what do you think that answer would be? Would it still say panda or not?
How strong your algorithm is.
How strong our algorithm
How
is?
strong your neural net is.
Okay, how strong my neural net is? But do you think it's a panda or not?
Yeah.
Yes, right? Or it's not? Yes. It is panda, right? Is there any difference between these two pictures? No. Okay, so let's see what machine tells us. It calls it gibbon. Yes. Okay, so now, so these are networks called as adversarial networks. You know, when, see, going back to this cyber security example, right? For every good thing, we always do a bad thing. Now, so people have come up with a fantastic neural network to say, I can recognize cat, I can recognize dog. What is the first thing that we as students who are sitting behind the scenes do? Chala, let me break this. That's fun, right? How do I give an input to this, which looks like, which is a cat, but the machine would classify as dog? So think of like all our hackers behind. First thing what they do is that, okay, let me create an input of these two, and then create an example that makes the model break. We call such models as, or the examples as adversarial, because they are against the right examples. Right? We are not feeding cats, but you actually find a gibbon, which the neural network would actually say as a panda. So, so this sort of networks are called as adversarial networks, but we'll use it for a good scenario. So, okay, so these are called as GANs. I'm going to skip this. Okay, so how did we come with this example of Fortnite to PUBG? So think of like, I'll go very fast here, just to give you a sense of like how is this being done. Imagine that you start with, you take the real Fortnite picture, and then we generate, imagine that I write an NN, a neural network, where all the real Fortnite pictures are given, and then real PUBG pictures are given. It learns something, what it learns is irrelevant for us. So something comes out of it, some fake of PUBG came out, right? And then we look at it and then click. We actually find out, hey, we write a discriminator function which is, say, hey, does this look real or fake? Just like how we did for panda, right? So, and give a score to it. Yeah, it looks real, it looks fake, then I relearn to a point where the generator function becomes good, right? So then what I do, so I take a fake one, enter, and then we regenerate the Fortnite back. Okay, so you're building, and then now what we do is that, okay, so I have this, I have this, I have that. Now how do I identify that this, what we want to shift is that, not this one, right? Because we wanted to convert one app into another app. So we are not more interested in this, but we just want to find out how much of error is present here. So to find that, what we do is that you do a pixel to pixel loss on this, and you reduce this. If you do that, then because this is actually mostly the same. This will look very similar to this. So that's how we call it this system is called as GANs, Generative Adversarial Networks. This is a new thing that is on range right now, because it is actually making AI creative. So what I have shown is not AI is no more classifier. It is creating visuals that we can't imagine. So I can take an apple tree and then convert it into an orange tree. I can take this classroom and convert this into something else altogether. All of you are sitting on a boat and then going somewhere without using Photoshop. Right, so, okay, so yeah, so this is how it actually looks. So imagine I have a Fortnite and feed a PUBG, then you get visuals that are exactly the same. So you get personalization of one, and then all you need is now build a system that sort of like puts them together and then generates. Yeah, okay. So I think I have more time, right? So yeah, so I'll conclude. Have we read? So is everything over? So should we? There's nothing to read further. We are just starting. We are starting AI right now. Like look at the problem statements we have. So and thanks to all the adversarial networks, for every good thing we do, there's always someone who will hack it, and we still have a job security, right? You will fix it, they'll hack it. You will fix it, they'll hack it, and that's how our life continues. So no, we haven't actually. Like one of the things is that we are at a point where a lot of things that were all manual and error prone. Think of like language understanding, language translations. Can we have someone who can speak in Gujarati to Marathi translations, or Gujarati to some very a local dialect in certain place that probably doesn't even have a script? So things that are completely impossible at some point in time can actually be enabled right now, right? So language. So we are at a point where we can go for that. Yeah. So So yeah, the chatbot here, the example was all about a farmer calling an expert and having a conversation, which today is extremely manual, can actually be translated into a dialogue manager that a bot can understand and converse. And the situations are that imagine that there is a pregnant lady out there in some village having stomach pain for the last 5 days. Should she go to the hospital or not? And the distance of the hospital is probably about 50 kilometers from where her village is. So should she go or not? So we need an AI system that is scalable to go and answer. Today there are so many of these problems that are yet to be addressed, and that's where I think we as Indians can actually go and solve. So that's where my team and like in Reliance, like we are part of AI Center of Excellence at Reliance Jio, and where we are actually building the horizontal. Think of like AI as a service. All the building blocks needed for India. So we understand Indian languages. We need to understand our language as service, and then speech, vision, our own knowledge graph, like our own homeopathy, our own naturopathy, which you don't find in Google at all. So can we get our own knowledge into a graph that we can actually go and start searching for, right? So that's the building blocks on which we are building stuff, and then goes into both helping the business of Reliance itself, like petrochem, retail, and so on, as well as how do we get benefits to Indians. So whether that be in agriculture, health, education, and security and so on. So thank you so much. That's me. So I think I have more time, but if you have questions.
The question is, how do you reduce the false negatives, especially where it is very critical? For example, in TF, we had a company and a startup, on the sound patterns of your cough, it will detect whether you have TB or not. Okay, now if there is a 5% error rate, then what would happen is, it would tell a person who has TB that you have no TB.
Right.
Right? That is very dangerous.
Right.
So there will be error margins, and especially where it is very critical, how do you deal with that?
I think, so I'll repeat the question. False positives or false positives in the case of healthcare, right? Misdiagnosis or false negative, how we look at it. So how do we deal with false positives or false negatives? I think the answer to that question is how humans actually deal with it. So let me actually step back a little, right? So if you take a medical report to 3 doctors today, not the flu example I gave, but the typical problems, right? all the three doctors give three different opinions. We had a nice term for that, calling second opinion, third opinion. But I mean, the short answer is that no two doctors agree on the same thing. How can machine agree on the same thing, right? Okay, so wherever the domain is extremely complex, like health or any place, right? The typical answer they give is that it depends. As humans, we accept that fact. That's okay. But as machines, I think we also need to accept that there are certain domains where there is no right or wrong answer at all. All the machine is actually trying to predict is what is the probability of this over that. We need to educate the consumer to take it that way. The problem is not on the algorithms. So I think when we actually like do predictions, we need to actually say that hey, the probability of this particular symptoms that are being expressed, whether that be through cough or images or so on, being TB is so much. Now you go and do this further test for.
No. So
Yes.
where normally you would have done a blood test or something, it would have given a perfect result.
Yes.
Now you're introducing something which is lightweight and which is easily portable and scalable,
Yes.
right?
Yes.
So if you did that, and then there is a false negative, then what would happen is that you would have told many people saying that you don't have, it is not a fuzzy thing. It's,
Yeah,
you would have told him that you don't have TB when he actually has.
Yes.
Otherwise you would have gone through that expensive test,
Yes.
right?
Yes.
So it is okay to say that, yeah, there seems to be some chance of it if you go for the further test, but if it turns it away and says that you don't have, that negatives have to be reduced to almost zero.
Right. Yeah, that's where we start. That's where hence the feedback loop is extremely important. So both the false negatives as well as false positives, understanding that So okay, so there are two things here, right? When do we think that the model is ready for mass consumption where you start delivering it? So imagine as part of the build phase itself, you look at n number of samples depending on the problem statement to ensure that the feedback loop errors are getting decreased as much as possible. So I think it goes on a case-by-case basis, and then that's where we make decision. So
It's a technology flaw. 100% we cannot rely on all the cases.
doctors only cannot say that.
That is what I am telling.
So
It's a technology flaw. We cannot,
no, but I think the core problem actually, that every false positive and false negative does not have equal weight in the decision, right? So there is a difference, right? So should I do this or not can actually cost you $1 billion. Imagine you are a VC and you're trying to invest. I came to you when Uber was Uber, right? So you didn't invest. The cost is extremely high, right? So there are many people who are like that. So, but that's where I think you have to weigh what is the cost of this decision, and you make an appropriate. About global warming.
Your AI related applications.
Okay. No, I think warming. AI can help people understand what global warming is. At some other, so there's a debate around it. Trump actually says, look, there is more heat in Arizona, and hence there is no global warming. So, or like look at how cold the winters are. So, and then you look at it and say, what the heck is he talking about? Global warming doesn't mean that if you are minus 50, there's no global warming. So, how do we educate people to understand the parameters that measure it?
To predict using AI, done other cases like the
Yeah, so-
prediction algorithms.
See, one is actually, okay, so let me go the 3 points, right? Like historically looking at certain places where heat is all BI, right? So it's all you're looking at the past saying here is where the heat map is. Can we predict where this year, this summer we are going to have a drawdown in India? So that's your prediction problem. Given that, what should we do to actually ensure that people do not suffer? Is your AI at the minimalistic cost. So should we send a water tanker of so many liters to Anantapur because this year there is going to be an extreme drought? So yes, we can solve it, but that's where I think if government comes in and everyone join us, where we sort of use the data and predict and then take those incentives, and then if it works, then we have solved it.
Thank you, Mr. Raghuram Lanka, for giving an excellent coverage. To thank you once again, I would like to request Professor Suresh Kumar to present a small token of appreciation for Mr. Raghuram. Please accept this.
On behalf of department, we are always proud to declare that the speaker is university our student Mahati. She is also university topper. She is a senior person in Microsoft. Both of them, Mr. Lanka and Mrs. Lanka, both of them always do come forward to help us whenever there is a technical requirement is there. I just made a call that Sir, it is our college. Always will be there forefront to come forward to enrich our expertise to share with us with our students. And the way he has presented, most of the all our students speak about the buzzwords like cyber security, cloud, AI, like that, simply speaking on the buzzwords only. And coming to the lab, experimental basis, they simply keep quiet. So, our algorithm writing is very, very important. We have shown the applications also. We are really happy, and the lecture is very informative. And the department is looking for your support for the subsequent events also. Thank you.
You are our guest now.